Ready? Okay. So let's consider a practical application for balancing chemical equations. Rockets work by burning a fuel in the presence of an oxidizer. So you have two different kinds of chemical that are in two different tanks in the rocket. In order to get good performance out of the rocket, you want the gases coming out to be hot and made of light molecules because that makes them come out faster, which gives you more thrust for the amount of fuel and oxidizer that you've burned. So to consider this, let's look at one case where your fuel is methane, CH4, and your oxidizer is liquid oxygen, O2. So you've got an equation like this. You've got methane and oxygen going into the rocket, and you have carbon dioxide, water vapor, and free hydrogen coming out of the rocket. And the question is, how much of each do you have? Well, you can see looking at this that there's one carbon on the left and one carbon on the right, so that balances. But there's one oxygen, or rather two oxygen atoms, one oxygen molecule on the left, and there's three on the right, so that is not in balance. So to make that balance, we need 3/2 of an oxygen molecule, or three oxygen atoms on the left, and now 1, 2, 3 on the right. We've got 4 hydrogens on the left, and 2 hydrogens here and 2 hydrogens there on the right, so now the equation's in balance. Carbon's got an atomic weight of about 12, hydrogen about 1, so a CH4 has got an atomic weight of about 16. Oxygen's got an atomic weight of about 16, or 32 for an O2. So 3/2 of an O2 gets you an atomic weight of about 48. 16 is 1/3 of 48, so you can see that you need 3 times the mass of oxygen as you do the mass of fuel when you size the tanks for this rocket engine.